union. And then the algorithm says that for the start symbol, we just put in end of input as a token. And then we do the rest. So you follow all these. So once you have your first and follow sets, it's now very easy to compute the pass table. And now following the algorithm, you should be able to do that. So once you have this, now we are ready to pass this grammar. So that's just showing you how we move from we're moving from a grammar that was not LL1 amenable to one that now, in fact, we have a parsing table for it. So this, we're just going to look at the strengths of LL1. We've said it can be implemented quickly. There are two ways to implement LL1 parsing. Once you have the parse table, you can use the table-driven design, or you can use recursive descent. I'd already read up on recursive descent. So in recursive descent, you define a function for each terminal, and then these functions call each other recursively based on the look-ahead token. So of course, at the beginning of your main program, the function you would call is the function for the start symbol. And then based on the look-ahead token, that function for the start symbol will call the appropriate non-terminal based on the parse table, and so on and so forth. So I want you to go read up and make a choice between whether you're going to use the table-driven design, so go read up how you implement that, or how you implement recursive descent, you're just using the LL1 parse tables. It gives us a fast execution times, whether it's table-driven or recursive descent powered, they're both fast, and they pass in the order of the length of the token stream and the size of the grammar. So actually, this was the last slide. So in summary, we've said top-down parsing. We try to derive the code from the start symbol, the grammar, and work through the parse tree to the leaves, which is basically the token stream coming from the scanner. We looked at BFS and DFS, and we said, whereas they are algorithms, they're not typically used in practice because they're inefficient. Then we introduced now predictive parsing, which is what we're calling the left to right, look ahead, leftmost derivation of one. You decide the length of the look ahead. So we've done LL1. Then we've said that to come up with the LL1 parse table, you must compute the first and the follow sets. And once you have that complete table, then you can implement it either using a table-driven design or a recursive descent design. We've seen the two types of grammars that cannot be parsed using LL1 parsing. So that's a grammar that has left recursion or that has left factorability. And we've shown you how to eliminate both cases, so that if you look at your grammar and you find it, there's a left recursion somewhere, we've shown you how to implement right recursion to eliminate left recursion, and also how to left factor to remove left factorability to ensure that we have unique productions for all our non-terminals. So the next steps from here is basically to implement your parsers, okay? So already you have your scanners, and hopefully they're producing the right tokens for the grammar and generating error messages where you have an invalid token. Now, the next step is for you to implement LL1 parsing, and you choose either recursive descent or you're going to use a table-driven implementation scheme, and now build your parsers for the same grammar. And remember, you came up with sample code that you're using to test whether your compiler works. So we hope that that's the same. You just now interface your scanner to your parser. So I'm going to give you 2.5 weeks to implement the parser. Sometime next week, we will look for time to assess the scanner. And then you'll have 2.5 weeks to implement the parser. The parser is usually the hardest bit. But once you've understood what we've done in terms of top-down, you've understood how to compute the first and follow sets for your grammar, you've understood how to populate the parsing table, the rest is actually very straightforward. It's really just about coding, okay? So I will post all these in the classroom with the deadlines for the submission of the parser. Yeah, so get working pretty hard because the time is not on our side. In the meantime, as you work on that, we'll be going through the other topics. So we're going to look at bottom-up parsing as the next approach, but we're not going to implement anything in bottom-up, but it's good for us to understand because most commercial parsers actually use bottom-up parsing. And then from there, we'll go on now to the other topics of code generation and code optimization. Then we'll be done with the bulk of the lectures. Then you'll be left now to just finalize on the programming. So apologies once more. I feel even worse because I've been talking to myself for like 10 minutes. But anyway, all the very best. So have a good rest of the evening. Okay, bye.